Right, our strategy for this when we're solving exponential equations. So we've never had exponential equations before, right? We've had equations that we're solving quadratic, we solve linear, we solve all sorts of things, but never an exponential equation. So this is a new thing that we are doing. Our two strategies are write both sides with the same base. So you're going to try to write both sides with the same base, if possible, and then you set the exponents equal and solve. Okay, so that's one strategy. So that's strategy number one. The second strategy, if that strategy is not possible, that's kind of our best strategy, the easiest one to use, the first one that I would look for. The second one that you can use is you would take the log of both sides, then use power rule to simplify, and then solve. Okay, so you would log both sides. So when I say log both sides, okay, so let me go over a couple things here. So the first strategy is this one. The first strategy is if I have 2 to the 3 equals 2 to the x. We know that this follows then that this must equal this, right? Those exponents, so you would say therefore 3 has to equal x. That's our first strategy. If you can change it to the same base, if we know it's 2 to the 3 equals 2 to the something, then we know logically that the 3 must equal the x. And if you have extra variables around it, so if I say plus 1, then 3 would equal x plus 1, right? So whatever's in the exponent here, I would set the exponents equal. Good for strategy 1, right? Get the same base, set the exponents equal. That's strategy 1. Strategy 2 is what if I have something like this? 2 equals 3 to the, what was I trying to do? 3 to the x, like this. And I go, okay. But I can't change those to the base of 2. I can't change them both to the base of 3. I cannot make them both the same base. So one strategy is we would log both sides. You are allowed to log both sides. They said base 10 because why choose a different base? Why do base 7 if you can just do base 10? The other strategy you have is that if it's this x in the exponent, you can change from logarithmic or exponential to logarithmic forms. You can go back and forth. So there's actually two different strategies there. So you can log both sides. If possible, you would just bring the x over. So here I can bring the x down and then solve, right? So this is a new strategy that we're using where I can log both sides. The logging of both sides, and again, we're going to do some examples of that. So if you're like, how does that work? I'm going to show you. Logging of both sides, one thing I wanted to point out is if I log both sides, this is the same thing as me doing something like I can square both sides, right? I'm allowed to square both sides. Yes? I'm allowed to square root both sides. If I had 2, am I allowed to square root both sides? Yes? Like that. Okay. So I don't want you saying I'm going to do the opposite and I'm going to divide both sides by log. That makes no sense. So you cannot do this. I never want to see that. I have seen it, which is why I'm telling you not to. You're not dividing both sides by log to get rid of the logs, right? You're not doing this. No. Right? That makes no sense. That's the same thing as I'm going to divide both sides by a square root. Can I do that? That just, right? You're like, that's why I would square both sides. Right. So to get rid of the log, you're not dividing by log. People think it's like a number. It's not a number. It's like me saying I'm going to unsquare root something by dividing by it. That makes no sense. So I don't want to see this anywhere. If I see that, I'm taking marks off. You don't divide the log out. Okay, because I've seen this before. I just don't divide by log. When you do this, then you would say, but logically 2 equals this. So I do therefore. So watch the process that I'm writing. So if you're writing something funny like this, I have to take marks off because that doesn't make any mathematical sense. Is that okay? So if you want to do something like, but I divide both sides, you don't divide. It's like me dividing by a root. Right? Square root. That doesn't make sense. Okay, so if you want to write something differently, make sure you ask because I've seen people try to divide it out, which it's not what you're doing. Okay, so then we're going to log both sides. So you're allowed to log both sides. I usually choose a base of 10 rather than a different base because it's easiest. Then you use power rules to simplify and then get through that. So logically, if I have this, and we did look at this, I think, briefly. So if I have, say, log base 2, and I had something like this, and I said, so x, then you would say, oh, but by logic, therefore, I think we ended off with an example like that, right? So then we said, but by logic, therefore, x has to equal 4. Right, that was one of our examples from the previous bit. Okay? Does that make sense? So you're setting them equal. Good, good. But you're not, so what I don't want to see, and that's what I was mentioning, I don't want you seeing divide by log base 2. Like, that's not what you're doing. You're not dividing by it. You're saying logically, if I have the same log on both sides, therefore it follows by logic that x also has to equal 4. Okay, so I don't want to see dividing by log base 2. Okay, so there you go. So that's our method. So now let's try some of them. So when we look at it, we decide which strategy is best. So for this one, I can see that they both have 9. There's a 9 and a 3. So this one has a base of 3 if I choose to make it a base of 3. So 9 is actually 3 squared. So I grab this guy, and I say this is actually 3 squared. Then I put the rest of it still around it. Okay. Then you go and then you simplify this and you go, okay, then this is 3 power to the 2x equals 3 to the 5. And then it follows by logic, right? And I don't want to see you dividing by 3, right? You're not dividing by 3. You're saying logically this now has to equal this. So you're saying therefore it follows that 2x equals 5. Don't show me divide by 3. That's not what you're doing. You're saying, but if they both have the same base, then therefore the exponents must equal each other. Right, so that's the part where I'm like, don't write a funny step, because I will mark what you write. Right, and I'll be like, okay, that doesn't make sense, that you can't write that. So then you get 2x equals 5, so therefore x equals 5 over 2. Good? Okay, so it follows logically that this now is equal to this. Here, 8 to the 2x minus 3 equals square root of 32. Yes?
Would you need us to write therefore?
Sorry?
You
You don't have to write the therefore. I'm going to write it just to remind you that it follows logically from that. You're not dividing from it. So it doesn't follow you. It's always, it follows, right? You're always used to saying it follows or therefore. Or, yeah. Yeah. You don't have to do the therefore. Okay, but you're grabbing the two exponents. All right. Good. Yeah. So ask that. So you don't need the therefore, right? So just, but it follows that the exponents now equal each other. Here, 8 and 32. Hopefully you've done enough exponent stuff that you know that both of them have a base of 2. Right, both of them have a base of 2, so I'm going to do, this is 2 to the 3 for the 8, right, and that is keep the rest on the outside, so 2x minus 3, and this 32 is 2 to the 4, right, 2, 4, 8, oh, 5, sorry, 5. That's me. 2 to the 5 is 32, and then square root is 1/2. Right, so simplify that up, and then you're going to set the exponents equal to each other. Or you can grab the exponents now. It's up to you. I'm going to simplify it first. I'm going to go 2 to the 6x minus 9 equals 2 to the 5 over 2. Right, and then it follows, right? So therefore, 6x minus 9 equals 5 over 2. You don't have to do the therefore. I'm just doing it to kind of trigger you remembering that the exponents are now equal. So you're grabbing this, and you don't have to box it. You're saying that those two equal each other. Okay, so just for your notes. Then when we're solving this, we go ahead and solve it, and we go x equals, bring the 9 over, so add 9, which is 18. So this will be 6x equals 23 over 2. And then x equals 23 over 12. All right. All right, so this next one here, like we said from the last lesson, if x is already on one side, right, so x is already on this side, you don't have to change form, you don't have to do anything, it's just a regular solving question. So some of these are regular solving questions. You'll see, wait, you already asked me this before? I know, it overlaps some of the stuff, so they're doing exponential solving, but this is logarithmic, so I'm just going back and forth, just so that you've got the memory of exponential, logarithmic, they're inverses of each other. So if it's already solved for you, you don't have to do anything. Some people go and change form, right? So again, if the x is already isolated, just solve the whatever I give you. So this one's not even exponential. It's just find 2 to the exponent what equals 1 over 16. So you should hopefully know that that's a negative because it's reciprocal and negative 4, right? So you should be able to just solve x is negative 4. So that one is not even exponential, just reminding you of, right, when you isolate and when you don't. Okay, so I'm just reminding you, don't forget how to do this stuff, going back and forth. People sometimes forget how to do this once I've taught you something new. So you don't have to do anything fancy. X is already isolated, just solve the right side. All right, so more strategy. So now I'm just going to make the questions longer. So here, right, so this is just simple, one side to one side. Now, when I solve this, so look, see the step when I'm setting the exponents equal to each other? See how it's 1, 3 with a 3 here, right? And then I set the exponents equal. Here, there's a 2 and a 2, so then I set the exponents equal. I cannot have 3 terms. 1, 2, 3, no, right? It doesn't work that way. I need the sides to be balanced, same base, set the exponents. Same base, set the exponents. Here, it doesn't work with 3 terms. Is there anything I can do to simplify it first to make it so that it's going to be 2 terms? Yes. So your strategy here is simplify when possible. So simplify if possible. Okay, so we're adding strategies as we go along. So simplify if possible. So yes, I am allowed to bring the 10 over. It's not doing, so you know when you're allowed to simplify and how you're allowed to simplify. We know all the rules that we need now. So you know when you can and you can't. Is that 10 disturbing anything? No. So it can join up with the 15. So we've got 5 to the x plus 4 equals 25. That's good. Can we change that to the same base? We definitely can. So we're going to go 5 to the x plus 4 equals, and this is 5 squared. Can we set the exponents equal? Yes, because it's a single with a single. Then this is the part where we grab the exponents and set them equal. And again, you don't have to do the therefore, and you don't have to do the box. I'm just trying to emphasize when I'm doing it. And then x is negative 2. That's it. Okay. So looking at the next one, what is my strategy? I go, this is 3 terms. I would have to simplify, try. This is just 2 terms. Can I change them so that they're the same base of 2? Yes, I can. 2 to the 3, 2 to the 4, 2 squared. I cannot change them. Sometimes people get stuck because they go base of 4. That's a base of 4. And they go, I can't do a base of 4. You don't have to. You can still bring the 4 down to a 2. So as long as they're the same base, you don't have to bring it up to the base of 4. I know those 2 match. You can bring it down to the lower base of 2. Okay, so you don't have to choose 4. You can go, no, 2 only works with this one. So 8 is 2 to the 3, right? And then keep the outside. 3 to the x minus 2. 16 is 2 to the 4, right? And then here, 2 squared to the 4, to the x. Does that make sense? Right? 4 is 2 squared. So you don't have to bring it to a base of 4 just because that has a base of 4. Because I know over here we brought it to a base of 5. These guys here, we brought it to a base of 3. These ones, both of them, I brought them to a base of 2. So you choose the base that all of them can become. So 2 works for this, not 4, because the 8. Then you go ahead and simplify. So we're going to get 2 to the 9x minus 6 equals, you can do this a bit faster. This would be 2 to the 2x, power to power. If you want to skip that step, you can go right here to 2 to the 2x plus 4. So we know how to, when you multiply, you add the exponents. So if you want, you can go right here. Right, so you can skip to this step if you want. Right, and I want to see the 2x plus 4. Then you set the exponents equal. You don't need the therefore. I'm just emphasizing it for our notes. Then I'm grabbing the exponents and setting them equal. Okay, so when they're both single base, set the exponents equal. And solve. So then we're going to solve. So here we're going to bring the 2 over, so it'll be 7x equals 10. So x equals 10 over 7. Okay. All of those were changed to the same base other than C, which was just don't forget how to do a logarithm, right? Here, okay, here, we cannot change it to the same base, right? We cannot change to the same base for sure, for sure, for sure. So instead of changing it to the same base, if you want to leave, you can go. If you don't need to be here, just don't be here. Watching you smile at your phone is irritating. Okay, so this one you cannot change it to the same base, for sure, for sure, for sure. So we got 3 to the x and we've got a 10, right? Definitely not. I made it very obvious. There's no strategy you can make it the same base. So this is the one where you would usually, I would just change it to exponential form. Or sorry, to logarithmic form. If it's exponential, change it to logarithmic. If it's logarithmic, you can change it to exponential. You've got those two strategies. So here, I'm going to change it to, so change to log form. Okay, that's my strategy. So I'm going, okay. So if I can't do anything else, I'm going to change it to logarithmic form. So changing it to logarithmic form, I'm going to grab the exponent equals log, and it's of 10, and the base is 3. That's it. And then you stop there. If I can't solve it, I can't solve it. So that's kind of why I want to show here. This one, if you can solve it, keep going. This one, I can't do anything else, so stop here. That's beautiful. It's exact. We want you to leave it exact. It's gorgeous, lovely, love it. Okay, so leave it there. So yes, if you can keep going, but if you can't, then stop there. It's gorgeous. That's a beautiful, beautiful exact log. Okay. Next question. Here. So looking at strategies, we go, okay, changing it to the same base. There's 100 for 2.3. Can't change that to 2.3, no. Can't change that to 2.3, no. Is there anything I can do to simplify? So now looking at our strategies, right? So change it to the same base. So this one here was same base. Same base strategy for sure, right? We use that a bunch of times. Same base, right? So this one was same base. So our strategy here, same base. Here, simplify, then same base. Here, can I do same base right away? No. Can I simplify those? So look at our simplify. Can I simplify? Am I allowed to divide both sides by 4? Am I doing anything mathematically wrong? No, if I divide both sides by 4, you are allowed to. So you know what rules we can and cannot do to simplify. So then you go 25 equals 2.3 to the x over 2. Try not to do a slash there. It sometimes gets confusing to read. Try to do it vertically. Okay, right there. So I cannot change that to the same base. So I'm now back to here. So it's exactly the same question, just with different bases. So grab the exponent. So grab the exponent. We're going to change it to change, so simplify. So my strategy here was simplify first. And then now change it to change form. So change to log. Right, change it to log. And now we're going to change this to log. So we're going to go x over 2 equals log of 25, and the base is 2.3. Am I done? What's wrong with this? Shouldn't have the 2 there, right? But mathematically, you know how to get rid of a 2, right? Divide by 2 on there, you would bring it over to the other side. So that stuff is still the same. So division by 2 will become multiplication. So we're going to go x equals, and you just put the 2 up there. In front, not after. Hold on. You might have a question like this. But, so that's beautiful. That's gorgeous. That's a good answer. I would accept that. I think I would accept that. That's okay for me. There's another form that you can do. So now that we know the properties tell us that you can also bring this up, right? So multiplication becomes exponential. So we're going to go, not exponential, but 2 to the exponent of. So the or, so I'll say or. You can also do log 2.3 to the 25 squared. And then you kind of go, would I leave it squared? And I would go or. I would finish it and go log base 2.3 of 625. So all of those are okay, right? All of those are okay. Okay, all equivalent, all okay. So 25 squared, 625. When you check your answer in the back, you have to understand that there's different ways. They may have left it like this, they may have left it like this, or they may have done 625, right? So when you look at your answer, you go, oh, it's equivalent, it's the same. Okay. Next one. Now, looking at the strategies. Can I simplify? Can I simplify? Can I divide anything by 3? No, right? Because there's a 3 to the x and 3 to the x plus 1. Can I bring anything over? I can't. Can I change them to the same weight? Even if I try to change them to the same base, there's a plus in between. The plus in between is the problem, because even if I change it to the same base, I can't gather the like terms. I can't add the exponents. I can't do anything. So there's a new strategy, which we have not done very much. But for this one, you are allowed to, and again, we're not as comfortable with exponential. The only exponential we've done really is calculating it. So last year, all we did with the exponential was calculate. We did a bit of graphing. That was it. So that's why you're not as comfortable with the exponential. Logarithm, same thing, right? So the comfort level with logs and exponential isn't great. Again, before we used to teach this in 11, so you had 2 years of it. So if it feels a bit uncomfortable now, that's why. It's just because it's our first time. So the strategy with this one, when you're looking at this, you go, wait, I wish I could do that something with the 3 to the x, right? Because look, they're the same, right? 3 to the x, 3 to the x. Because they are a common factor. So if you looked at that and went, huh, but why are they the same? They're actually a common factor. So I'm going to rewrite this. So 3 to the x plus 1 is actually 3 to the x times 3 to the 1, yes? Plus 3 to the x equals 36. Does this part here, this is this. 3 to the x plus 1, we're breaking it apart. So all we've done is we've always gone forwards. I gave you this, 2 terms, so I would say 3 to the x times 3, and you'd go, oh, that's a 1, so that's 3 to the x plus 1, right? You know to add. If I gave you 3 to the 2, or if I gave you, let me try a different one, if I gave you 6 to the x, and this is what we did last year, we would go 6 to the 2, and I'd say, can you combine those? You go 6 to the x plus 2. So we did a bit of that last year. We were doing combining, and I gave you variables on the top. Or I would say 6 to the x and 6 to the 2x plus 1. You go, oh, okay, I add them, so it'll be 3x plus 1. So we did that last year, right? We would do this stuff, but we didn't do backwards. So now we're going backwards. So here, you notice that there's 3 to the x. And you're like, oh, I wish I could do something with that. It's tempting. It's because it's a common factor. This broken up is 3 to the x times 3. This is 3 to the x, still normal. So if I was to common factor this out, so this here is going to be 3 to the x. That's where you're looking at going, boy, I wish I could do something with that. They're the same. They're the same. They're screaming at you going, I'm the same, which is a common factor. They're the same 3 to the x. Now write down what's left over. So we're going to write down what's left over. It'll be 3, right? The 3's left, and a 1, because you factored it out, and 36. Does that make sense? Okay, so then this, keep the 3 to the x, work this part out, and that's just a 4 now, equals 36. And now based on looking here, right, and I put them beside each other, we know that if there's just a common factor, not common factor, a common multiple here, it's 4 times that equals 36. It's not doing anything. I am allowed to divide by that now, right? It's just a number. You know mathematically, if it's a number times that, I'm not doing anything wrong if I just divide both sides by 4, right? So that's okay. So just like this, I put it right beside. So then I've got 3 to the x equals 9. There we go. And now we can solve it. Okay. I don't need to see you change it to the same base when it's simple, right? When it's simple like this, you can go 3 squared, and then therefore x equals 2. I don't care if you just go straight from here to here. So I know that you can do it squared in your head, right? When it's a simple like 2 3s and stuff, you can go, oh, I know what the exponent is. You don't have to show me change to the same base. But that's what you were always doing in the past. Like that's what you did in your head. You were actually changing it to the same base and then solving. Okay, so that is new. right? That's new. We've never done backwards. We were common factoring it out, so that's new. So you're looking for, but it was probably calling to you. You're like, I wish I could do something with that same 3 to the x. It's there, the same. And that's why I was calling to you like, oh, it's the same. Okay. Another one, different type. Okay, so the exponential one's a little different. Now, I have one way I'm going to show you, and then I'm going to show you another way. So there's two perfectly wonderful ways to do this one. I'm going to show you one the way that I prefer, okay, but both are totally fine. So if we have 3 to the x and we have 5 to the x minus 1, okay? For this one here, again, can I change it to the same base? Strategy number 1, change it to the same base. Cannot. Nothing I can do to make a 3 into a 5 or a 5 into a 3, so can't do it. Can I divide anything or simplify? So strategy with that was simplifying. So simplify, can't simplify, nothing to simplify, nothing to gather over. So my idea here is that I would like to hopefully change it to something like this. I know it's exponential, so anything exponential can be inverse so I can get it to logarithmic form. That's my goal. So I want to be able to do this. So my goal is to change it to this form. So something to the x equals something. So I want to change this. But because they're broken up like this, I'm going to do this part here where I'm breaking it apart. So I'm going to take the 3 to the x, leave that alone. This is 5 to the x times 5 to the negative 1. Does that make sense? I'm breaking it apart. Again, the new strategy that we didn't do before. So 5 to the x minus 1 is actually 5 to the x and 5 to the negative 1. Okay. Then I want to bring all the x's to one side. I want to bring all the x's to one side. How do I bring all the x's to one side? I'm going to divide both sides by the 5 to the x. You are allowed to divide by the whole thing, because then that whole thing goes away to become 1.